Welcome back to the show, everyone. Today, we're going to be doing a deep dive into something pretty iconic and surprisingly Canadian, the Canadarm.
Yeah.
And we've got all sorts of cool stuff to work with here. Museum descriptions, encyclopedia entries, even a magazine article.
Right.
All about this robotic arm. You know, it's really become like synonymous with space exploration at this point.
It's really fascinating, isn't
Yeah.
it? Because it's not just about the arm itself.
Right.
It's about this incredible journey of technology and how it reflects Canada's kind of growing footprint in space.
So you're saying this isn't just like a Canadarm history lesson. We're looking at the bigger picture.
Exactly, yeah. We're going to uncover why this invention captured the world's imagination and what it tells us about where robotics and space exploration are headed.
All right, I'm intrigued.
Yeah.
Let's start with the basics. What did the Canadarm actually do?
So imagine you're on a space station. You need to move heavy equipment, position astronauts for spacewalks, even grab and repair satellites.
Wow.
That was the Canadarm's job.
So it was like the astronaut's Swiss Army knife.
Pretty much, yeah.
Yeah.
And the Smithsonian description mentions a surprising fact.
Okay.
You know how in those iconic photos it looks so smooth,
Right.
graceful, moving these massive objects around?
Yeah, it always just looks so effortless.
Yeah. Well, on Earth, the Canadarm couldn't even support its own weight.
Wait, what?
It was designed specifically for the weightlessness of space.
So something that can move a bus in orbit can't hold itself up down here.
It's true. It's all because of the materials. Lightweight graphite epoxy, Kevlar,
Right.
designed to be strong enough for the tasks, but light enough to launch into space. It really shows how engineers have to think differently when they're designing for that environment.
That's amazing. And you mentioned it could do more than just move things around. I was reading the Wikipedia entry before the show, and it goes into detail about deploying, retrieving satellites, even acting as a giant ladder for astronauts during repairs.
Yeah.
I mean, if you need a tool that versatile up there, this is it.
Absolutely. The Canadarm was truly revolutionary for its time.
Yeah.
It changed the way we think about robots in space and what's possible. But the story of how it came to be, well, that's just as fascinating.
All right, so spill the beans.
Yeah.
Where did this incredible piece of technology come from?
The Canadian Encyclopedia points out that the Canadarm program actually began in 1975, which is interesting because
Because that was before the Canadian Space Agency even existed.
Exactly, yeah. But here's the kicker, and this comes from a University of Toronto article. What really caught NASA's eye wasn't some fancy space gadget. It was a robot designed for Canadian nuclear reactors.
Hold on, we're talking about a nuclear reactor robot leading to the Canadarm. That's not what I was expecting.
It just goes to show you that innovation can come from the most unexpected places, right?
Yeah.
These engineers were solving complex problems, and those skills turned out to be perfect for the challenges of space robotics.
So this wasn't some overnight success story. It was years of problem solving
Right.
leading up to this iconic invention.
Yeah. And the challenges didn't stop there. Building the Canadarm was a feat of engineering. Even some of the brightest minds thought it might be impossible. See, they needed to make it lightweight and flexible, but that created a whole new set of problems.
Well, yeah. I mean, a giant flexible arm in space sounds like a recipe for disaster if you can't control it perfectly.
Exactly. And controlling it was the problem. The University of Toronto article mentions how scientists were baffled. They needed the arm to have 6 degrees of freedom. Think of that as being able to move in any direction like a human arm.
6 degrees of freedom. Okay, that's a lot of flexibility. But why was that so hard to manage in space?
Think about it. You got this arm, weightless, with all these joints rotating in different directions.
Yeah.
And you're trying to control all that movement with absolute precision,
Yeah.
knowing that even the slightest miscalculation could, send the arm spiraling out of control.
Yeah. No, I can see how that would be like a nightmare to program
Yeah.
and control. So how did they solve this seemingly impossible problem?
This is where the ingenuity of a Canadian engineer, Professor Hughes, comes into play.
All right, Professor Hughes, let's hear it. What was the breakthrough moment?
Well, Professor Hughes, he realized that the key was to change how they were thinking about the problem. You see, up until that point, they were trying to control the Canadarm by calculating its center of mass.
Okay, that makes sense. The center of mass is like the balancing point.
Right, exactly. But the problem was that the Canadarm's center of mass was constantly shifting as it moved and flexed. Like, imagine trying to balance a pencil on your finger while it's also bending and twisting.
Yeah, good luck with that. That sounds impossible.
And that's what everyone thought. Controlling this flexible, weightless arm just Way too complex. But Professor Hughes had a brilliant idea. He said, what if, instead of focusing on the arm's constantly changing center of mass, we use a fixed point as our reference?
So basically, find a solid anchor point and work from there.
Precisely. And what better anchor point than the shuttle itself? So instead of trying to wrangle this moving target, he anchored the calculations to the shuttle's attach point.
Ah, that's clever. Like using the steady hand to guide the less steady one.
Yeah.
Did that actually simplify things enough to make it work?
It was a game changer. Suddenly, the math became manageable, the control systems more reliable, and the astronauts could operate the arm with more confidence. It was a true eureka moment, born out of thinking outside the box.
Wow, so this Professor Hughes was a real visionary. And to think this all came from his experience with nuclear robotics, that's a pretty impressive example of how seemingly unrelated fields can actually inform and inspire each other.
Yeah. It's a reminder that innovation often happens at the intersection of different disciplines. You never know where the next big breakthrough will come from.
Well, I'm glad someone figured it out because thinking about an out-of-control robotic arm in space is not my idea of a good time. But I'm guessing they didn't just take Professor Hughes' word for it and send this thing up into orbit, right?
You're right. They needed to be absolutely sure it would work as intended. And that's where those wonderfully named simulators come in. Rigid and Assad.
Okay, remind me about these simulators again. The names are catchy, but I need a little refresher on what they did.
Right. So remember how we talked about the arm needing 6 degrees of freedom? Well, Rigid was the simpler simulator. It focused on the arm's basic movements, without the added complexity of flexibility. It was like a first draft, just to make sure the fundamentals were sound.
Got it. So Rigid was like the training wheels for the Canadarm. And then Assad came along and said, all right, time to take off the training wheels.
Exactly. Assad, which was nicknamed All Singing, All Dancing, was the more advanced simulator. It incorporated all of Professor Hughes's complex math and simulated the arm's flexibility, how it would respond to forces, even how it would interact with objects in the weightlessness of space.
Wow, so they really threw everything they could think of at it. That must have required some serious computing power.
Well, remember, this was back in the early days of computing. The U of T article mentions they were using punch cards to run the simulations.
Punch cards. That's almost ancient history in the world of tech. I can't even imagine trying to program something that complex with punch cards.
Right. It gives you a real appreciation for how far we've come. But even with those limitations, the simulators were amazingly accurate. When the Canadarm was finally tested in space, it performed almost exactly as predicted.
That's a real testament to the skill and ingenuity of the engineers and programmers.
Yeah.
They were pushing the boundaries of what was possible, even with limited technology. So all that testing and refining, it must have been quite a moment when the Canadarm was finally ready for its first mission.
Oh, it was a huge moment for Canada, and really for the world. This was a major step forward in space exploration and robotics. Everyone was eager to see if the Canadarm could live up to the hype.
I bet there were a lot of nerves as they watched it go up on that first mission.
You can imagine. This was the culmination of years of research, design, and testing.
So tell me, did it work? Did the Canadarm deliver?
Oh, it delivered in a big way.
Oh, good.
The first mission in 1981 was a resounding success. Deployed and maneuvered a scientific payload right on schedule. And that was just the beginning.
So this wasn't just a one-time publicity stunt.
Right.
The Canadarm actually went on to have a real career in space.
A long and illustrious career, over 90 missions. Working with all 5 space shuttles, each mission, seemed to push the boundaries of what we thought robots could do.
Like what kind of things? Give me some highlights.
Well, there were those crucial Hubble telescope repair missions. Imagine trying to grab and fix a delicate instrument like that while orbiting hundreds of miles above Earth.
Right.
And remember when it helped assemble the International Space Station piece by piece? It was truly groundbreaking stuff.
It's incredible to think about those iconic images of the Canadarm, like holding on to the Hubble or lifting those massive modules into place for the space station. It really became a symbol of what was possible with human ingenuity and robotics.
It's true. But sometimes it was the smaller moments that really showed the Canadarm's versatility. There was that time it had to knock off a chunk of ice that was blocking a waste exit on the shuttle.
Wait, they used this $1 million robotic arm to chip away at ice?
Hey, In space, no task is too small if it means keeping the crew safe and the mission on track. And that's what's so fascinating about the Canadarm. It wasn't just about performing specific tasks. It was about solving problems, adapting to unexpected situations, and showing that robots could be reliable partners in space.
You know, it strikes me that the Canadarm's success wasn't just about the technology itself. It was also about changing people's perceptions of robots.
That's a great point. The Walrus article talks about the Canadarm's role in ushering in the era of collaborative robots.
Right.
Machines designed to work alongside humans, not just as separate entities.
And that collaboration is everywhere today, isn't it?
Right.
From factories to hospitals, robots are becoming more and more integrated into our lives.
Exactly. And it's amazing to think that the Canadarm up there in space was one of the pioneers of that movement. It helped build trust and showed the world that humans and robots could work together to achieve incredible things.
We even see that legacy here on Earth with those spin-off medical robots, Kidsarm and NeuroArm. They're using the same precision and dexterity to perform delicate surgeries, helping people in a whole new way.
It's a legacy that extends far beyond the Canadarm's original mission. But the story doesn't end there, does it? The Canadarm's technology has continued to evolve.
Right. We have Canadarm2 on the International Space Station, and now Canadarm3 is being built for the Lunar Gateway, that new station that will orbit the moon.
And there's a significant shift happening with these newer versions. They're far more autonomous. They can make decisions and perform tasks with less direct human control.
Which makes sense, right? As we venture further into space, we need robots that can, think for themselves.
Think about it. The communication delays between Earth and the Moon,
Yeah.
let alone Mars, would make real-time control impossible. We need robots that can adapt to changing conditions, solve problems on the fly, and even repair themselves in some cases.
It's both exciting and a little bit daunting to think about how far robotics has come. And to think this journey started with a robot designed for Canadian nuclear reactors.
It's a reminder that sometimes the most groundbreaking innovations come from unexpected places.
Yeah.
And the Canadarm story is a testament to Canadian ingenuity, perseverance, and a willingness to push the boundaries of what's possible.
So as we wrap up this deep dive, I'm left with a question. If increasing robotic autonomy is the key to exploring deeper into space, what does that mean for the future of work, both in space and here on Earth?
It's a question worth pondering. As these technologies continue to evolve, they will undoubtedly shape the way we live and work, both on this planet and beyond.
Well, I think it's safe to say that the Canadarm's legacy extends far beyond its, impressive list of accomplishments in space. It sparked imaginations, inspired generations of engineers, and changed the way we think about the role of robots in our world.
Absolutely. And who knows what other incredible innovations are waiting just around the corner. The future of space exploration and robotics as a whole is filled with possibilities.
So next time you see that iconic robotic arm gracefully maneuvering in space, remember the ingenuity, the challenges overcome, and the Canadian spirit that made it all possible. And maybe, just maybe, it'll inspire you to dream big and reach for the stars.
Keep looking up and keep asking those big questions. Until next time.